Okay, so for farsightedness, then you can't get the lens thick enough to see nearby objects. The image falls in behind here, and we need a lens that's going to help us converge the rays more quickly. In other words, a convex lens or a converging lens. Okay? Now, the third problem that's pretty common with eyes is something that's called astigmatism. Astigmatism. And astigmatism is about the shape of the lens. When someone has astigmatism, and it's actually fairly common, it means the lens doesn't have the same shape, the same focal length at all spots. So it might have one focal length in one section and a different focal length in a different section. And it means that we have a hard time focusing on objects going objects going horizontally and vertically. So like back here, when you're looking at a nearby object, things in the distance will be blurry because you can only focus on one. Or if you're looking at a distant object, things nearby will be blurry because that's just the way our eye has to determine, are we going to make it thin or thick? And if objects are in the middle, then the lens will be, its thickness will be in the middle. Okay, but when you're focusing on one thing, the objects in the other spots will be blurry. Well, with astigmatism, take a look at this picture. Someone with astigmatism would look at this picture, and maybe the horizontal lines would be clear, but when the horizontal lines are clear, the vertical ones are blurry, or the diagonal ones are blurry. Like they can't get them all clear at the same time, even though they're the same distance from their eye. And it's because different parts of their lens has a different focal length. Okay? Now, we used to be glasses was the only solution for astigmatism, but you can now have contact lenses, because contact lenses are now weighted, because it would be very important that like the right part of the curve of the corrective lens match the right part of your eyeball. So in early contacts, you put them in, they floated around, they wouldn't necessarily match up. But for people with astigmatism, now the contacts are weighted so that the heavy part swings to the bottom and then it matches the curve on your eye. Okay, laser eye surgery can also help astigmatism because it can change the curve. It can kind of burn off the edge and change the curve. Laser eye surgery can also help people who are nearsighted who can't see far away by trimming this lens a little, making it thinner since they can't pull it thin enough. It will not help farsighted because you can't burn pieces onto your lens, only off. The other part that people usually ask about when we're here are cataracts. And cataracts are like a growth that ends up growing on the lens. And now cataract surgery involves using a laser to take this growth off. It's like a buildup of almost calcium or something, I think. And it interferes with the light coming into your eye. Because remember, there's a pupil here, and the pupil is like the opening in the camera. It's the aperture that lets the light in. All right, one last thing. I want to go back for a second to talk about compound lenses, just for another minute. So you did a few questions on them. Usually, the main spots that you're going to see compound lenses are microscopes, telescopes, binoculars. Some projectors too, but I just wanted to point out these three because I'm thinking, where would you use them in your life? Okay, in a microscope, they tend to be up and down, obviously, and they tend to be both convex lenses, right, with the slide down here. And so the slide is usually between f and 2f, so that the image will be real and larger, and beyond 2f, the image of the first one, right, the DI1, which becomes the DO2, and the DO2 then usually ends up between f and the lens. And because it ends up between f and the lens, then this lens is acting like a magnifying glass, right, which is what you want for a microscope. but it also means the image is virtual, and so this one will be inverted, and then the next one will be erect, and so what you end up seeing overall will be the image will be upside down compared to what you started with. And for those of you that have used microscopes, you should realize that's exactly how it is. Telescopes and binoculars are really the same thing. A binocular is really just two telescopes strapped together, so you have one for each eye, and it gives you depth perception, right? If you only have one eye, then you can still see everything. You just don't have a sense of how far away stuff is. It's why people who have no sight in one eye aren't often allowed to drive, because they don't have a perception of how far away things are. Okay, there are different types of telescopes. So there is some, and binoculars. So some telescopes would have two convex lenses. The first one flipping the object over so that the first image is upside down, and then the second one flipping it back so that the overall image is the same orientation as the object was. But there are some telescopes and binoculars that have a convex and a concave. And the ones that do that, so this one would flip it over, and then this one wouldn't flip it back, and it will end up in here. But often these ones end up having a prism inside of them, or two prisms inside of them. So the light goes from the lens through a prism, it's usually rectangular, that turns the image 90 degrees, and then through another prism that turns it another 90 degrees, and then back to the lens. So now it's been rotated so that it's now going to end up right side up. The other thing that these prisms do is it means our telescope and our binoculars don't have to be as long, because the path length here will still be like the DODI, but it doesn't have to be in a straight line, which is a handy thing. Okay, so that's the end of mirrors and lenses. There is a practice assignment, and in the practice assignment, the end ones are with compound lenses, so try not to worry too much if you end up getting an image that's flipped over and you're thinking, wait, it's a telescope, I shouldn't be looking at this bear that's upside down. Just know that in those ones there'll be prisms inside that will flip them around, okay? That don't change the math, just changes the orientation for you, okay? And next day we will start atomic.